I'm going to go over practicing problems that help you to do well on your group activity 2 and test 2. I didn't create practicing problem for group activity 1 and test 1 because I thought it was very easy. Okay, but it could be my opinion only. But for 2, 3, and week 4, I will do practicing problem for sure. Okay, question 1. Evaluate the given expression and express the result using the usual format for writing numbers. And you are given permutation 2 out of 44. So that means 44 factorial, open the formula. I explained when I was doing homework. 44 minus 2 factorial, and that's equal 44 times 43 times 42 factorial over 42 factorial. 42 and 42 is gone, and you get 44 times 43, which will be 1892. Next one. Decide if the situation involves permutation, combination, or neither. Explain your reasoning. The number of ways 20 people can line up in a row for the game tickets. Does the situation involve permutation, combination, or neither? The key word here is lined up in a row. Why? Because if you are in the line, are you going to push somebody out of line and say, nope, I am going to get first? No, of course not. You're going to stay in line and wait until your time comes to buy the ticket, right? Therefore, what will be the answer? Is order important? Of course it is important. So what is going to be the answer? Permutation. Next one. Determine whether the following problem involves a permutation or a combination and explains your answer. How many different two-letter passwords can be formed from the letter A, B, C, D, E, F, H, and if no repetition of letters is allowed? The key word here is two-letter passwords. When you have password, can you mix up letters? Type, let's say you have A, F, and if you type F, A, will it work? No, of course it's not gonna work. So if it's a password, that's it, that is everything. You have to go in the same order you created your password, which means it's gonna be what? Permutation. Next, a class has 35 students. In how many ways can 6 students form a group for an activity? So how many ways 6 students can create a group for an activity? So we have to choose, when we are selecting some amount of element out of total, we are using either combination or permutation. So it's clear it's going to be either combination or permutation, because you are not choosing all of them, just only 6 out of 35. The question is it going to be combination or permutation? Now let me ask you this. Is it important which student you will choose first for the group? No, of course not. So it's going to be combination. And we are using 6 out of 35. And that is going to be 35 factorial over 35 minus 6 factorial times 6 factorial. Okay, so let's see. 35 minus 6 is going to be 29 factorial, which means this 35 I'm opening till 29. 35, 34, 33, 32, 31, 30, and 29. I made it. Okay, and okay, hold on, 6 I will open. Let's open 6. It's gonna be 6 times 5 times 4 times 3 times 2, okay, times 1, I'll put 1. So 29 is gone with 29. Next, what do we have? 6 I can cancel with 30, 6 will be gone. 30 divided by 6 is 5. 5 I can cancel with 35. Here will be 1. Here will be 7. 35 by 5. 4 I can cancel with 32. Will be 8. 3 I can cancel with 11. Will be 11. 2 I can cancel with 34. Will be 17. Or you could cancel with 8 also. Doesn't matter. So let's see, out of this mess, what do we have it left? 7 times 17 times 11 times 8 times 5. Okay, for the sake of saving time, let me punch the numbers. Times 17 times 11 times 8 times 5. I got 52,360 groups. So 6 students can create 52,360 groups from 35 students. Okay. Next one. A certain lottery has 20 numbers. In how many different ways can 7 of numbers be selected? Okay, since it's a lottery, never order, well, yeah, order is important, but not 7 number asking group. We are not talking about, actually no, order is not important at lottery at all. So, which means it's going to be combination 7 out of 20. And we are going to get 20 factorials over 20 minus 7 factorial and 7 factorial. That is equal 20 times 19 times 18. How much I have here? 20 minus 7 is 13. So I have to open till 13. Okay, 17. Wish me good luck. I have to go all the way to 13. 17, 16, 15, 14, 13. 13. Whew, made it. 7, 6, 5, 4, 3, 2, 1. 13 and 13 is gone. 7, yes, with 14, it's going to be 2. 6, it's going to go with 18, 3. 5, it's going to go with 20, 4. 4, it's going to go with 16, is 4. 3, let me cancel with this 3 this time. Okay, 2, and I will cancel with these 2. And what we have left? We have left 4 times 19 times 17 times this 4 times 15. Then that's it. And that's it. So that will be 19 times 17 times 16 times 15. Okay. And we got 77,520. Moving to next one. So, according to study, 70% of K-12 schools or the district in a country use digital content such as e-books, audiobooks, and digital textbooks. One second, let me see if I can. No, I want it formatted nicely, it's not working. So, audiobooks and digital textbook. Of this 70%, 12 out of 28 use digital content as a part of their curriculum. Find a randomly selected school or district uses digital content and uses it as a part of their curriculum. So what we need to find out, digital content and using as a part of curriculum, right? So we need to find out probability of digital content, and this is symbol of and. There we go. And a part of their curriculum. Part of curriculum. Okay, that's enough. So, which means, first we need to find probability of digital content, right? And then we need to find probability of where it's part of curriculum. Okay, this content, let me rewrite. Okay. And then since we have here and, what we're gonna do, we're gonna multiply. Yes? Okay, so how much is probability of digital content? Let me see. It's gonna be, the study 70% of our district in the county use digital content. Here it is, 70%. So it's gonna be 70%, which is gonna be 0.7. Yes? Now, what's the probability that they will use as a part of their curriculum? So 12 out of 28 use digital content as a part of their curriculum. So 12 out of 28, which is 12 divided by 28, it's going to be 0 point approximately. When it's approximate answer, you put this tilde, two tildes, approximation, meaning not straight, just about 0.43. So from here, this is going to be, the answer is going to be probability that using digital content and that content is a part of curriculum, it's going to be 0.7 times 0.43, and that will be 0.301. So it's going to be about 30%, right? Okay. Next, one thing I want you to pay attention closely, that it always tells you in parentheses till what decimal notation, till how to round, shortly saying, till how many digits to round your number. And I believe they are asking for decimal notation, not for percentage. So read in parentheses where it's asking for answer, underneath it always says read carefully. And one more thing, if you see, let's say, there is a rounding issue, or let's say you put 0.3 and they ask for 0.30, so then contact me, I will give you credit back, okay? Because it's a software. We can't rely software to act like human and understand that 0.3 and 0.30, it's the same thing. Okay, next one. A doctor gives a patient an 85% chance of surviving bypass surgery after a heart attack. If the patient survived the surgery, then the patient has 30% chance that the heart damage will heal. Find the probability that patient survives the surgery and heart damage heal. So keywords here: survive surgery and the heart damage heal. And in between them is and, which means, remember, when we have and, we multiply. When we have or, we add. So we need to find probability of survivors, the surgery, probability of heart damage heals, and at the end we multiply both probabilities. Yes? Okay. Excuse me. So, what is the probability of survivors, surgery survivors? Doctor gives a patient 85% chance of surviving bypass surgery. So 85%, 0.85. Probability of the heart damage heal. So 30% chance that heart damage will heal. So it's given. We don't need to calculate anything. 0.3. Now we are coming into play this end, which we are going to do probability of survivors. With your permission, I won't write down the whole 9 yards within in parentheses, times probability of heals. And I get 0.85 times 0.3. And the result is 0.255. Next. The response of 1,000 adults in a certain region to survey question about the story of Britain's vote to leave in European Union are shown in accompanying Pareto chart. There we go. Pareto chart. Here are keys. So find the probability of randomly selecting an adult who thinks the story is somewhat important. Somewhat important. Which one has somewhat important? That's a C. If I go to the C, it is going to be 351, right? Here it is. So out of total, how many we said? 1,000. So probability here of somewhat agrees is equal 353 over 1,000. This is 353, which is equal 0.353. Next, randomly selecting an adult who thinks the story is not important at all. Where is not important at all? Here it is. And which is E, and we have 155. So in this case, not at all, they count important. It's going to be 155 over 1,000, 0.155. Next one, randomly selected an adult who thinks the story is not too important or not all important. So we have two probabilities here connected. Not too important, not all important, and more importantly here we have or, which means we're going to end up with adding. So probability of not too important. Where is not too important? Here it is. So that is D, which is going to be here. 231. So it's going to be 231 over 1,000. That will be 0.231. So probability not at all important. We already have it right here, not at all. So 0.155. So which means, since we have or, probability of not too important plus probability of not at all important will be 0.231 plus 0.155, and that is equal 0.386. Okay. Next one. Randomly selecting an adult who thinks the story is extremely important or very important. So we have two probabilities: extremely important, very important, and connected with or. So extremely important. How much we have extremely important here? Oh, wait a minute. Yeah, extremely important is A. By some reason I thought 353 is extremely important. So anyway, I didn't pay attention. It's going from right to left numbers. Letters. Okay, extremely important. Here it is 117. So will be probability of extreme 117 over 1000, 0.117, and probability of very important, let's see how much is our very important. Here it is, it's B, which is going to be 254. We got it. 254 over 1000, which is equal 0.254. So if we add them up, so we will get 0.117 plus 0.254, and that would be equal 0. Wait a minute, this is, yeah, this is going to be, okay, 11, 6, 7, and 3, 0.371. Did I add correct? No, of course not. No. Gee. 7 times 4, 11, 6, 7, and 3. Yeah, very good. Next problem. Here we have table. Degrees got in the field, degrees got outside of field, and it's about male and female. So let's solve this problem. So first question. The student is male or received a degree in the field. Okay, in the field. So student is male, received a degree in the field, and or. So what's the probability of male here? Male or degree, right? Probability of male, since we have or, probability of degree in the field. So let's find out. Probability of male, it's going to be here 768. And then receive degree in the field. Where is it? Here it is. Receive degree in the field, 292. So which is going to be 768,279 over how much is total? Here it is 1770522. I don't even want to read it. 1 million and so forth. So plus, it's going to be degrees in the field total 2, 9, 2, 7, 5, 1 over 1770522. And the answer is going to be here is interesting thing. Here is interesting thing we are getting. Let me explain. Let me use this one. So male total 768. So I'm going to circle like this. Okay, the whole entire row. Degree in the field, I'm going to circle like this. So what do we get here interesting? Male and degree in the field, it's at the duplicating itself in this probability and this probability, yes? Because look, 158,557, we count in the male, here, let me highlight it. And we count when we calculate the degree, total degree. Yes? Total degree. So this 158 and 557, it's repeating itself and here. Therefore, we need to subtract. Okay? So otherwise we will get duplicate. So what's going to happen here? I'm going to do minus, let me get it, minus 1, 5, 8, 5, 5, 7 over 1770522. Now I can calculate. So if you put the numbers in calculator, then you would get 0.509. So do you understand this? Here I would add this. Let me do this here. Make a space. Okay. Move this part here. Going to move here, and then this one going to move here, or even better, the whole thing. There we go. So, and on this end, I'm going to clean this and these parentheses. Actually, and do minus probability of male. I wasn't paying attention last minute. I had a look and saw what's happening there. Male and, because that's an and, right? And of this 158,557, it's male and degree in the field, which is both these probabilities. Male and degree in the field. We got it. Okay. So 0.509. Why is it not pulling? Doesn't want to pull down. That's fine. We can survive. So next one, B. The student is female or received degree outside of field, which is going to be the same thing here, right? because when we are talking about female, the total females is gonna go in the row, and receive degree outside of the field, it's gonna go in the as a column. So column and row always cross each other, and then duplicate is gonna be 868049. So what we are going to do here, it is going to be total female. Hold on, let me write down probability. Of female, and we have here O, right? So we need to add practically female plus receive degree outside of field. That's going to be 1000. Okay, 1 million. Probability of degree outside. And minus the duplicate of female and degree outside. So what do we have here? So we are going to have, let me bring this down before I start writing. Okay, so we have 1 0 0 2 2 4 and 3, 1,002,243 over 1770522. Next, plus it's going to be degree outside, which is going to be 1477771, and out of 1770522, and minus repetition, the duplicate 868. We are eliminating duplicate this way. 049 over 1770522. Okay, and that is going to be equal 0.91. Okay, next one. The student is not female, which is asking for male. So is not female, not female, or, it's asking or, which means I know already I have to add, receives degree outside of field, receives degree outside. And I know that female is a row, in the row, degree is in the column, so we are going definitely have their duplicate, so minus probability of not female and degree outside. Okay, this is going to be equal. If it's not female, so it's going to be male, which is going to be 768,279. 768,279 over 1770522. You know what? I'm going to combine with like a common denominator, because denominator is going to be the same, just like here. It's going to be the same, so might as well. So to add and subtract when denominator is same, you can put one denominator. So 768,275 plus degree outside, Degree outside is 1477771 and minus 609722. Let me go up here. Male and degree here. Okay? And if you put these numbers together, you are going to get 0.924. All right. Next one. The percent of college students marijuana use, the sample of students is shown in the accompanying pie chart. Find the probability for each listed in A through D below. Okay. Randomly selecting a student who never used marijuana. So if we look at the pie chart, never used marijuana, 57.1. Okay, we have already answered. Next, randomly selected a student who used marijuana. So what do we have here? Used but not last days, used first through 9 days, used through 10 through 29, so did not use. So if I take one, remember the complement, if I 100%, I do minus with 57%, the ones that never used, I will have all times when the entire percentage that they used, right? Because never used plus used, it's going to give you 100%. Therefore, I'm going to do 1 minus 57.1, and I will get used percentage of people who used it. Let me see, 42.9. Okay. Next one, randomly selected student who used marijuana between 1 and 29 of the last 30 days. 1 through 29, here it is, 1 through 9, 10 through 21, 29. So these two together, which means 13 plus 4%. %. Next, randomly selecting a student who used marijuana at least once of the last 30 days. At least once. So this is, we have here, we have never used, which is 57%, right? How many was 57.1? And here we have at least once, or maybe more, or all the time. So what is it going to be? To get at least once, we are going to take the one they smoked between 1st and 9, which is going to be 13%. And then what do we have? 13%, and then plus 10 through 9, 29, which is 4%. And what else do we have here? Used all 30% plus 1.9. And that means you will get 18.9%. All right. Next question. A study conducted of the trend in the design of social robots. In a random sample of 104 social robots, 66 were built with legs only, 17 were built with wheels only. Let me write this out. 66 legs only. 17 wheels only. 8 both legs and wheels. And 13, neither one was used, neither legs nor wheels. Okay, use the rule of complements to find probability that randomly selected social robot is designed with legs or robot. So designed with legs, and total we have 104, right? What just happened? Sorry, my iPad went off for a second. Let me go. Please don't make me to find probability that is randomly selected for randomly selected robot is designed with legs or without leg. The easiest way would be to find probability with wheels. So that will be 17 over 104. That is 0.163. And then we have to do 1 minus probability of wheels, which will give me the rest. That will include legs or without wheels, right? And that will be equal 1 minus 0.163 is equal 0.837. Okay, and we answer one more question here. That will be the last one. So find probability that randomly selected social robot is designed with either legs or wheel or both, and we have or everywhere. So what is going to be either legs? So legs, we know it was probability with legs. It's going to be 66 over 100. I mean 66 over 104. 104 is 0.63. Probability wheels, we already have that one, is 0.163, right? It's right here. And lastly, both, probability of both. Here we have probability of both. So it's going to be 8 over 104. So 8 divided by 104 is equal 0.08. So if we want to know probability of, let me see, legs or wheel or both, what we're going to do, add them up. Okay, so if I add them up, probability of legs or wheel, so or both, is equal 0.63 plus 0.163 plus 0.08. We get 0.873. Just pay attention on your word problems. Maybe combination won't be exactly the way I have. It could be without legs, with wheels, with legs, without wheels, and so on. Just pay close attention, okay? Don't follow blindly to what you read here. Okay, and if there is any trouble, you can contact me. Okay, and I will record next homework.